Welcome to another problem session here. Now this is question number 11, and this is from the usual place I'm working with. This JEE advanced paper 1 of 2025 this year. Okay, some of the other years have worked out in this channel. All right, so this is actually a very good problem. Okay, so let's read it. So this is a solid glass, and refractive index is let me use a different color. So its refractive index is square root of 3, which is a reasonable value, and then there's a cavity here, air, which is n equals to 1. So this is half the radius of this bigger sphere, and the bottom is almost you can see there's a glass here, there's a tiny amount of glass here, so there are two interfaces here at the bottom. So the bottom, it will look like air, then glass, and then air again at O. It will be like that. So approximately they will be parallel. Okay. So inside that's what describing here, and that's point O. That's the point O. So this is, let's call that point O. That point is O. All right. So over here, an unpolarized light. So this is unpolarized, but it kind of makes it way through here. When it goes to O, makes it reflects around and refracts around, makes it all the way to point O. Whatever path it takes, at that point is going to get, so it's going to make it to O unpolarized. So you can say polarized in every which way direction, and then it reflects off here. Then when it reflects off, so of course it's going to be, this is the normal, so this angle has to be equal to that angle. These angles are equal. Then, but this guy is polarized. So you know this angle has a name. This is called Brewster's angle. This incidence angle, where you have a N1, N2, and N1 is less than N1, N2. In that case, it will polarize at a particular angle. Polarized means this polarism, say, can be vertical to the plane and in the plane. So it may be polarization this way and this way, that parallel to that. So this is, you can say, the air, and this is the glass. So parallel to the glass is this guy, and this is the polarization. So when it work out like that, it usually will come back parallel. I think that's where it is. But it is polarized. When it's polarized, this angle in this two medium, so this just will be in, it will be equal to, so what you have to know is tangent of this incidence angle. So this, not, they're the same, of course. So tangent B is n2 over n1. So first medium divides second medium, and second, that's what they wanted, this tiny you see that they wanted glass here a little bit because of they want this in the problem. All right, so if you look at it, and this is so this is equal to 1, and this is given as square root of 3. So theta b is 60 degrees. And this is important. Actually, this makes entire problem very simple because the way all the rays will work out is very simple. So let's draw rays and see where we go. Let me remove some clutter from here. And those I can't remove. Only the one that I wrote I can remove. Okay, so let's see. First I'm going to draw a normal here. At point at point O. So this is the normal at point O. Normal at point O. So this we can start from the end. We know at least one angle. This angle is 60 degrees. So it came in like that. Of course, you can reverse the rays. That's another way to think about it. It doesn't have necessarily. This is just a schematic things. So it's not necessarily happened over here. It could have happened somewhere else. We don't know where it happened. So you can trace backward from here where it could have happened. Or if you start from here, it will go over there, and then it's going to go over here, and there will be other complication. But the question is not really asking. It's just asking at what angle, what should the value of that angle, that incidence angle at which I should direct it. So start from here, and if you go down, it's going to come and hit somewhere here. And if you look at this circle, this is the center of the circle. From here to here, this is same as that. So this angle should be equal to same as that angle. So that angle is also 60 degrees. And because you're looking at this circle now, then this is the radius, so this is the normal. And let's call this point P. So this is a normal at point P. So this is the angle of incidence, yeah, or refraction. So this is going to go to another medium. So over here, you have medium air. Let's think as we are directing rays backward from what we want, and so we'll catch the ray over here. So it's going to come out some angle from this. So let's me say it's coming from this side of the normal, so it's going to go on the other side of the normal. So it's going to come out, it was going in that direction, but it's going to come out some angle. It's going to come out somewhere here. The question is, what is this angle? So let's do that angle. So say that's angle is x. So we have, this is a normal, this is 60 degrees, and that's the x, and this is n2, and this is n1. So these were the reversed rays. So 1 times sine 60 degrees equals square root of 3 times sine x we want. So sine x equal to sine 60 degrees over square root of 3, and of course this is nothing but half, because that's the square root of 3 over 2 over square root of 3, and those numerator cancel out like that, and then so this x is 30 degrees. So this angle from the normal is going to come out is at 30 degrees. Okay, so I am going to now draw out a little bigger picture so we can see it better. Okay, so here is a my attempt at really making a big picture here. So let me erase this. My pen slipped. And it's halfway, so it's going to be all right. Okay, so this is 60 degrees. So if this also 60 degrees. So you can see this is 60 degrees, but it comes out half as much. So half of this 60, so if you drop the from here, you can drop, actually this triangle is very simple. So this is that kind of triangle, equilateral. So if you drop from here to here, so in this triangles, this is 30 degrees. So, and we want 30 degrees here, like a double dot is 30 degrees. And single dot is 60 degrees for me in this picture. So if you draw horizontally straight, this was going to be, this angle will be 30 degrees. So it comes out horizontally. Pretty neat, right? So this comes out horizontally. It's very important for you to realize this comes horizontally. So now I'm going to look at this whole line from, let's call it Q, and let's call it, this point was P, and let's call it A, all the way to this line. So from here, the normal will, let me get a different ink. Let's get a green ink. Normal over here will go in that direction. So this is normal at Q. So this is the angle it hit, and then of course it's gonna, so that's the angle. If you in the original direction, it must have come from here, and then it went horizontal, and then went like that, and then it came out like that. So so that angle is angle of reflection, because it's the same medium. This is in N2, and this ray is N2. So this is a reflection, and this radial line is the normal line, and this is the tangential line at Q. So we want to get this angle. So and let's call this guy B. So we have a B, A, and let's call this guy C. C. So I have B here, C here, that's the R over 2, and I have this guy as from B to Q is R because it's a bigger circle radius, and this we want this angle. Of course, this angle is that. See, this angle is same as this angle, right? This angle here, this line here is let me clean it up and then I'll draw it again. Okay, so in a separate, I cleaned up a little bit, and so now it should be more clear. So this is R over 2, and from this geometry you can see that proceed this is you have a horizontal line A, B, Q, and you have a C, B, and P, and this is 30 degrees. So this must be 30 degrees. So that's 30 degrees here. Okay, so that's 30 degrees here. This is the radius of the smaller circles, that's R over 2. This is the radius of the bigger circles, that side. And so at the corner here is 90 degrees, right? That's 90 degrees. So if you look at this, let's call this the only thing that we don't know. I'm going to just call it Z. So in this big triangle, we want sine of that angle, because when this is the normal at Q. So the angle so the angle we want is this angle, which is same as that angle. So this also Y. So question is about find sine Y, and turns out this in triangle B A G B A Q, I mean B A Q, I should be able to if I get this divide by that, that's going to be sine of Y. Or you can use, so sine of Y will be R over 2 plus Z divided by R. Okay, so we need to figure out Z. But Z, using this smaller triangle, I should be able to figure out Z. So in triangle, this triangle, you have R over 2. This is Z, and this is 30 degrees. So Z is R over 2 sine 30 degrees. It's R over 4. Using this over here, it gives R over 2 plus R over 4 over R is 3 over 4. So this is the answer. So going back over there, they want the answer sine of theta. That's the one I called Y, and this 3 over 4. Okay, so there may be other answers, but this is the answer we arrived at by actually following the ray. Right. So that's it. The next problem. Bye.